This video, we're going to use Euler diagrams to uh, evaluate the validity of an argument. An Euler diagram is a special type of Venn diagram that we've been um, talking about already in this set of videos, which helps us examine universal and existential quantifiers and exactly where the element is that we are trying to draw the conclusion about. We put a little X there to say where it is to see if it's valid to make the conclusion. So we're going to start off with the premise that all clowns wear makeup. So here's wears makeup. And clowns are inside of that, right? Bozo is a clown. So there's Bozo the clown. Therefore, Bozo wears makeup. Yes, the X is inside of the wears makeup circle. So this is a valid argument. All lawyers wear suits. Wears suits. Lawyers. There. Jack wears a suit. Jack is a lawyer. So I'm going to put it on the, put the X on the edge here. There's Jack. Because I don't know for sure if Jack is a lawyer or not a lawyer. I just know that he wears a suit. He could be outside. He could be inside. So this is an invalid argument. If I don't know where something is, I put it on the boundary to show it could be either place in an Euler diagram. All snakes have fangs. Things with fangs. Snakes are a subset of that. Terry's pet does not have fangs. So Terry's pet. Therefore, Terry's pet is not a snake. That's a valid argument because our X that's outside of things with fangs has to be outside of the set of snakes since all snakes have fangs. Okay. No surfers speak French. So here's speaks French. Here's surfers. Pierre speaks French. Right? Therefore, Pierre is not a surfer. It's valid, right? Okay. It doesn't have to do anything with the truthfulness of the premises. Just assuming these two premises are true is the conclusion valid. Yes. Pierre speaks French. He can't be a surfer because no surfer speaks French. All right. Let's keep going here with the next few problems, and we'll not just discuss the validity of the argument, but the structure of the argument. If you are hot, you will sweat. So hot. I have this backwards. Sweat. Hot. If you are in the circle here, hot, you are definitely in the circle of you will sweat, right? James is hot. There's James. Therefore, James will sweat. Yes, that's valid. This is in the form of if P, then Q, P, therefore Q. The fancy name for this is called modus ponens. Just a second. And a less fancy name that's not Latin for this is called affirming the hypothesis. Okay. So that's our structure. Clear our canvas here. If you break curfew, you will be punished. Thelma was punished. I don't know, though, why she was punished. It says, therefore, Thelma broke curfew. This is invalid, right? And this type of error here is called affirming the conclusion. It's in the form of P implies Q, Q, therefore P. This is a converse error. Is the more formal name for that. Number 19 says, if you try hard, then you will succeed. People who succeed are out here. People who try hard are in here. You did not try hard, you will not succeed. So it doesn't say trying hard is the only way to succeed. So you didn't try hard, but you may succeed or you may not. So this is invalid. And the unofficial name for this is called denying the hypothesis. It's in the form of P implies Q, not P, therefore not Q. And this is more formally known as an inverse error. Okay. And we're going to wrap up this video with number 20. Say, if you cut me, I'll bleed. I do not bleed. Therefore, you did not cut me. That's valid. It's in the form of P implies Q, not Q, therefore not P. This is in the informal name of this is called denying the conclusion. And more formally, this is called modus tollens. And it's related to the idea of the contrapositive. Because we said that this statement before, when we talked about the contrapositive, is logically equivalent to that statement, that not Q is going to imply not P because of the contrapositive. So that's, again, if you're in a formal logic class, discrete math class, something like that, you're probably going to call this modus tollens. If you're in an informal logic situation, maybe like quantitative reasoning, you might use a phrase like denying the conclusion. So that was a valid argument. All right, we're going to stop this video there. We'll come back next time, and we're going to use this type of notation right here next time to evaluate the validity of a chain of conditional statements. And we're going to use the structure of arguments to decide whether the conclusion is valid or invalid. See you for the next video.